3. 5.4, number 3. Now, on your quest, we will be solving equations just like this, but we'll be doing them in radians. So we're going to do this example in degrees, and then on the next page there's some examples in radians, okay? So we'll go ahead and do this one in degrees just so you get your practice. How do I know it's in degrees? What's my clue? Yep, 0 to 360. That tells me that my calculator needs to be set in degrees for this problem. All right, now, essentially, you have two variables in this equation. You have a 2x and you have a plane x. What you need to do is find the formula on your sheet, which you don't have memorized yet, but you will. What is the formula or the identity for the sine of 2x? What is the identity? I turn this on. What's the identity for the sine of 2x? 2 sine x cosine x. So that's the first thing we do. You cannot solve a problem that has a 2x and an x in it. So since we have formulas to deal with the 2x's, we're going to take care of it. Now what do you think we might do? We've talked about this kind of problem before. You know, take a wild guess. You're stranded on a desert island. The cannibals are coming to eat you. If you don't do something here, are you going to let them eat you, or are you going to try something? Okay, so Reed has bravely suggested that we divide both sides by sine, which is definitely something that would occur to you, but Hector is saying, no, Mrs. Ford, you told us we couldn't do that. You can't divide by a variable. So it's a great option, bravely suggested. Can't do it. What else could we try? Well, certainly there'd be nothing wrong with dividing by 2, but that isn't really helping me toward a solution. What? Huh? What, Jacob?
Was someone talking?
No, I was getting ready to say something, but you go ahead. I'd rather hear you.
Oh, well, I was going to make the suggestion of like changing cosine or translating it to something else. I don't know if that would work in this situation.
Okay. We almost never want to change sine and cosine. Almost never. Okay? So again, bravely suggested. Try not to go to here. Guys, what do I like to have my equations equal to? 0. Oh. So could I make that happen? Subtract the sine. Now, it's all on the same side of the equation. What do you notice about the two parts of the problem? I can factor. They both have a sine. So I can factor a sine out. So now I have sine and then 2 cosine minus 1. Once I factor, what do? Set them both equal to 0. So sine x equals 0, or basically cosine x equals 1/2. Is that okay with everybody? Now, tell me about 0. When somebody says sine or cosine or tangent equals 0, what do I have to think about? The circle. So I'm going to think about the circle, all around the circle, going all around. What variable is sine associated with? Y. So where around the circle is y 0? Right here and right right here, right? So those two answers in degrees are 0 and 180. Now, what about cosine 1/2? Well, where does that happen? In quadrant 1 and 4, how do I know? Cosine's x, and x is positive in 1 and 4. Cosine is 1/2. I heard somebody say 30. It's actually 60 because of where the 1 and the 2 are there. That's a 60-degree angle. So your first quadrant angle is 60, so we'll add that to the list. What is the fourth quadrant angle? 300. And there are the answers to the problem. Okay? Now, guys, really, we've solved that kind of equation before. The only new part was this first step right here. That part's new. You have to be able to change the two x's into plain x's. All right, let's try one more in degrees. Do you want to do B or C? I don't care. B or C? B? All right, so B it is. It looks very, very similar. All right, so same direction. So what do you think we should do to get started? All right, we can certainly subtract cosine, but you have to be careful here. You can't factor anything. I know you see two cosines, but they're different variables. One is a cosine 2x, and one is a cosine x. And those aren't split upable. You can't factor out a plain cosine. It has to be a cosine x or a cosine 2x. So what are we going to do? We're going to switch our cosine 2x. And you don't have it memorized yet, but you will. What are you going to substitute in for cosine squared? Oh, I gave it away. For cosine 2x. Cosine squared minus sine squared. Now, guys, that's a problem now because this is trouble. It doesn't match everything else. But you know, because you have it memorized, what can you do with sine squared? Read. 1 minus cosine squared. So we're going to take, carefully, we're going to change the sine squared into 1 minus cosine squared. You can always change cosine squareds and sine squareds into the other one. They have to be squared, but you can always do it. These parentheses are important though, because there's a negative in front that's going to have to be distributed. So we have cosine squared minus 1 plus cosine squared minus cosine equals 0. Well, that's a real mess. Is there any cleaning up we can do? So 2 cosine squareds, and I'll just say minus cosine minus 1. What about that? Factors. Yep, it factors. That's a quadratic. That's like having the equation 2x squared minus x minus 1. Wouldn't you try something like this with that kind of equation? So what are those factors going to be? This is what you had to do on the middle problem on the quiz, by the way. You had to factor it. So let's see, this will be a 2 cosine and a cosine. It has to be a 1 and a 1. Let's see. That one's negative and that one's positive. When I FOIL that back, see how it gives me what I want? What?
How do you get the 2 out?
This 2? Okay, if I'm going to factor this quadratic, then I have to have a 2x and an x, so that when I multiply, I get 2x squared. Okay, that's how I did it. I'm factoring this. So 2x, or 2 cosine x times cosine x is how I get 2 cosine squared. If I didn't put that 2 there, I would only get regular cosine squared. Okay? Foil that. I mean, you're not even writing anything down, but literally foil that out, and you'll see this is what you get. All right, so now what do I do? Set them equal to 0. So if you can do that in your head, that's fine. That first one's going to say cosine x equals negative 1/2. And the second one's going to say cosine x equals 1. Now, we just talked about that one, sort of. Where does the cosine equal a negative number? 2 and 3. Because cosine is x, and that's where x is negative. So in quadrant 2 and 3, I have a cosine of negative 1/2. Which once again makes my reference angle 60, right? But 60 is not an answer this time. You have a 60 in quadrant 2. So that means that. So how big is that? 120. And then you have a 60 in quadrant 3, 240. 180 plus 60, 240. So those are the answers for that part. Now, what about cosine equals 1? That's on the circle. How do we know it's got to be on the circle? Because adjacent and hypotenuse can't be 1, can they? So it has to be on the circle. And it is x. So where is x? 1. At 90? At 0. At 0, yep. The only place the cosine is 1 is right here. Over there it's negative 1. Well, the way the directions are written, 360 isn't included. And really, we never include 360 because it's the same as 0. So one or the other, but not both. In this case, we'll use 0. Okay. All right, that's a lot of work. Big problem. Okay. Let's look at 4a, which is exactly the same kind of problem. Actually, it's about the exact same problem, isn't it? Let's look at 4b instead, because it's a different problem. It's similar, but it's not exactly the same. All right, so we're looking at 4b. Okay, so everything's exactly the same. We're going to do everything exactly the same, except these are our directions. We haven't had to use a calculator, so it doesn't really matter, but if we need a calculator, it'll have to be set in radians for this problem. Okay, here we go. What's step 1? Subtract the 2 sine x. All right. These are not the same thing. I hope you see the difference between these two expressions. Those are not the same thing. Okay, now what? Change sine 2x into 2 sine x cosine x. Look at it carefully. What do you think? We can factor, this time we can factor out a 2 sine. And that will leave me with cosine minus 1. So now what? Now we can set them both equal to 0. Are both of those going to be on the circle? Where did the 2 go? Okay, remember, if you say 2 sine x equals 0, you can divide by 2. If it weren't set equal to 0, it would matter, but since it's a 0, it doesn't matter. Okay, so I'm looking at my circle. We're in radians, yes we are. So where is the sine 0? Sine is y. So that's 0 at 0 and pi. Where is the cosine 1? That's x. Isn't that 0? We already have it, so those are the answers to the problem. 0 and pi. Alright, I left out one because A was the same. So I'm going to do one, throw in, cross out for A, and throw this one in its place, and we'll need a calculator for it. We'll do one with a calculator. How about solving, same directions, how about solving all right, we'll use our calculator on this. Here we go. But we obviously got to do some work before we get to the calculator. So what would you suggest? Take out a tangent. Sure, that factor. You can take out a tangent. And that will leave us with what? 4 tan minus 3. Okay, now what? So tangent equals 0. There's a 0 now, so I'll have to go to the circle again. Or tangent equals, if I do this in my head, 3/4. Yeah, so let's do the 0 first since we've already got this up there. What's tangent? Tangent is not y and tangent is not x. What is tangent? Y over x. And if that's not processing, you just memorized for this quiz, tangent is sine over cosine. Can you connect that to y over x then? Sine over cosine? So y over x. So you need y over x to be 0. So basically you need y to be 0. So where does that happen that y is 0? 0 and pi. I don't need a calculator for that, but I am going to need a calculator for this one, right? Okay, but first, where are you going to get answers? Quadrant 1 and 3. And we know it's 1 and 3, folks, because in 3, y and x are both negative, so that would give me a positive number. So I'm going to change my calculator to radians if it's not already there. And how do I figure out an angle from this? What do I have to type? Yep, so second tangent, 3/4. And I got 0.64. So one of my answers is 0.64 right here in quadrant 1. And then how do I get the other one? Reed, is that your phone? How do I get my second answer? Oh, no, not pi over 2. Oh, no. It would be pi plus pi, or 6/4, right? So plus pi, 3.79. And that, or those are my answers to that question. So there's nothing different on the calculator except the angles aren't 30s and 60s and special things like that. Okay. All right, well, let's look at the next page. And you're going to need your formulas for this page. These problems look so scary. But I don't want you to be scared. I want you to take it one piece at a time. So, you are told that the sine of alpha, so the sine of the angle, call that A. If you're bothered by the alphas, call it A. You are told that the sine is 3/5, and you are told this about it. What does that tell me about angle alpha? It's in quadrant 2. So I'm going to go ahead and draw a picture of alpha in quadrant 2. And the sine is 3/5. Now, if you haven't learned anything else, you know that when you have two sides of a triangle given, you're going to find the third side, right? And how will you find the third side? This is a right triangle, so how will we find the third side? Okay, so 25 minus 9 is 16, so this must be -4. Anyone have a question about that? We know why it's negative? Okay. All right, so that takes care of alpha. Now, beta, or B if you prefer, has a cosine of 5/13, and it's here. What does that mean about beta? Quadrant 4. And its cosine is 5/13. So I'm taking all this one little piece at a time. What's the third side of that one? 169 minus 25, 144, -12. So I haven't done a problem yet, but I have set up pictures for what I was given. Now let's look at the first problem. Find the sine of alpha plus beta. Well, you have a note card, you're going to need it for this one. This is not one of your memorized ones unless you just did it. What formula will I be looking at if I have to find the sine of alpha plus beta? U plus V, sine U plus V, one of my sum formulas. So that one says you take the sine of the first, U, cosine of the second, plus the cosine of the first, sine of the second. Your sheet has U's and V's. Do exactly the same thing, but use A's and B's, alphas and betas. Now, do I know all the parts of this formula here? Can I look at my two pictures that I drew and plug in all that? So sine alpha is 3/5. Cosine beta, 5/13. Cosine alpha and sine beta. So far, so good? What do I need to do now? Multiply these two. And I know you can cancel, but don't, because see how the two pieces are going to have a common denominator? And if you cancel, they won't. So just don't cancel. Just leave that 15/65. And this is going to stay plus because those are both negative. So that'll be 48/65. And the answer is 63/65. All right, let's try B. Oh shoot, don't erase, I guess I can erase all that. Keep the pictures. Keep the pictures. Because B uses the same given. Now we're doing the tangent of alpha minus beta. All right, so on your note card, which you don't have yet, but on your sheet, what is the tangent of alpha minus beta? What's the formula? Tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Yep. That's straight from my note card. That's not confusing at all. I just have to find the formula that does the tangent of an angle minus an angle. U minus V if you use the same letters as on the sheet. Certainly when you do your note card, you can make them X's and Y's or A's and B's or P's and Q's, whatever you want. All right, so tangent of alpha, -3/4 minus tangent of beta, which is -12/5 over 1 plus -3/4 times -12/5. Now that's a real mess. I'm going to go ahead and do a little simplifying here. So -3/4 plus 12/5, because I've got the double negative. And then I'm going to multiply that together. So that's going to be 1 plus 36/20. And again, I know that reduces, but I'm not doing it. You'll see why in a second. I'm not reducing it. You can. It's just unnecessary. Is everybody okay getting from there to there? Okay. Yesterday, or whatever day it was, we ran into a few of those. We called them complex fractions. And while you can simplify it in many different ways, I really think the fastest way is to look at your fractions. What's the common denominator of all of them? 20. And just multiply everything by 20. Now again, there's no police making sure this is the way you do it. I think this is the easiest way, but if it's easier for you other ways, do it other ways. The 4 will cancel out and leave me with a -15. The 5 will cancel and leave me with a 48. 20's 20. The 20's cancel and leave me with 36. So on top I have what, 33, and on the bottom I have 56. Now, since that is my final answer, if that reduced, you'd want to go ahead and reduce it. But it doesn't, so that's it. Okay? Everybody okay with that? All right. So I'm going to stop there. And prepare for the end of the day blessing. And if anybody is